Imagine taking a deep breath on a world that isn't your own, filling your lungs with a strange, alien mixture of gases, and preparing to let out a shout. On Earth, we live in an acoustic paradise. Our atmosphere is a perfect blend of nitrogen and oxygen at just the right pressure to carry the nuanced vibrations of our vocal cords at a crisp 340 meters per second. But the moment you step off this planet, you realize that your voice is not really yours. It is a collaboration between your biology and the physics of the world around you. We are going to embark on an epic, detailed journey through every major body in our solar system to understand the terrifying, hilarious, and haunting ways the universe would rewrite your identity. This is the story of how sound dies, screams, and transforms across the cosmos. Our journey begins at Mercury, the smallest and innermost planet, a world of impossible contradictions. Mercury is a sun-scorched pebble, so close to our star that the sun appears 3 times larger in its sky than it does on Earth. Here, the daytime heat is enough to melt lead, reaching 427 degrees Celsius, while the nights plunge into a deep freeze of minus 179 degrees. But for your voice, the most defining feature of Mercury isn't the temperature, it's the emptiness. Mercury is essentially a naked planet. It lacks a true atmosphere, possessing only a thin exosphere made of atoms blasted off its surface by the solar wind. For sound to exist, it needs a medium, molecules to bump into one another, and carry a vibration. On Mercury, there is nothing. If you were born here, evolution might grant you a stocky frame, a thick layer of internal fat to regulate your temperature, and perhaps even metallic skin to shield you from radiation. But you would be a silent creature. You could stand an inch away from a fellow traveler and scream until your lungs felt like they were bursting, and not a single vibration would reach them. The sound would die the instant it left your lips. However, there is one terrifying way to hear on Mercury. If you were to press your ear directly against the rocky, sun-baked ground during a Mercury quake, you would feel the sound. The vibrations wouldn't travel through the air. They would travel through the crust and into your jawbone. You would experience the planet not as a sound, but as a deep, subterranean thrumming, a haunting, wordless music of shifting stone. Mercury is a world of absolute, eerie stillness, where the only voice is the ground itself. Because there is no air to provide resistance, the movement of the ground would feel sharper and more violent than an earthquake on Earth, echoing through your skeleton like a strike on a tuning fork. You would have to learn a language of touch and vibration, communicating through taps on the ground or by pressing your helmets together to allow sound waves to bridge the gap between 2 internal air pockets. If Mercury is a library, Venus is a heavy metal concert. Leaving the silence behind, we dive into the most terrifying acoustic environment in the inner solar system. Venus is often called Earth's twin because of its similar size, but the similarities end there. Venus is wrapped in a thick, choking blanket of carbon dioxide that creates a surface pressure 90 times higher than Earth's. Standing on the surface of Venus is equivalent to being 1 kilometer deep in the Earth's ocean. To survive here, a Venian version of you would need a skeletal structure made of reinforced bone and a body designed to withstand crushing weight. But what happens when you open your mouth to speak? The air on Venus is so heavy, so soupy, that it behaves almost like a liquid. Your vocal cords would have to work incredibly hard just to push through the resistance of the gas. But here is the strange part. Because the gas is so dense, sound waves travel much faster than they do on Earth. moving at roughly 410 meters per second. This creates a disorienting, terrifying effect. Your voice would be transformed into a deep, booming growl with an immense amount of bass. Even if you have a naturally high-pitched voice, the Venian atmosphere would turn you into a rumbling giant. Imagine the voice of a massive predator, distorted and vibrating with such power that it feels like a physical blow to anyone listening. It is the Donald Duck on bass effect, a fast-moving but incredibly deep roar. Communication on Venus wouldn't just be heard, it would be felt in the chest of every person standing near you. The very air around you would feel like it's vibrating with every syllable, turning a simple conversation into a physically exhausting event. Your ears would also need to be different. The delicate eardrums we have on Earth would likely rupture instantly under the pressure. So a Venian human would likely have thicker, more rigid membranes or fluid-filled canals, similar to those of deep-sea creatures, to balance the external force. Furthermore, because of the extreme heat, the air density varies wildly with small changes in altitude, meaning your voice might actually bend or refract as it travels, making it difficult to pinpoint exactly where someone is standing, just by the sound of their shout. Moving outward to the red planet, we encounter the exact opposite problem. Mars is a cold, desert world with an atmosphere so thin it's practically a vacuum. If you were born on Mars, the low gravity, only 38% of Earth's, would allow you to grow tall and lanky. You might look like a giant, but your voice would be your weakest feature. The Martian air is 95% carbon dioxide, which has a very specific and strange acoustic property. It is a low-pass filter. This means the atmosphere loves to absorb high-frequency sounds. On Earth, our voices have sparkle and detail, but on Mars, that detail is deleted. If you tried to shout to a friend across a Martian crater, your voice would arrive sounding flat, muffled, and incredibly quiet. It would be like trying to have a conversation through a thick wool mask while standing behind a glass pane. The thin air simply cannot carry the energy of your shout. Even the loudest scream would carry only a few meters before fading into the rust-colored dust. Mars is a world of secrets and hushed tones, where the environment itself conspires to keep you quiet. To be heard, you would have to stand face to face, almost touching, making the red planet one of the loneliest acoustic landscapes in the solar system. Furthermore, because the speed of sound on Mars is slower than on Earth, about 240 meters per second, there would be a noticeable delay in conversation over even short distances. If you were shouting at someone 30 feet away, you would see their mouth move and wait a fraction of a second longer than usual for the muffled sound to finally reach you. It would be a disjointed, frustrating existence, where the silence of the desert is always trying to swallow your words. Interestingly, because the temperature on Mars fluctuates so wildly between day and night, the speed of sound actually changes by dozens of meters per second, depending on whether the sun is up, meaning your voice would sound slightly faster and more coherent during a Martian noon than it would during a freezing midnight. The true comedy of the solar system begins when we cross the asteroid belt and reach the gas giants, starting with the king of the planets, Jupiter. Jupiter has no solid surface to stand on. So imagine you are a citizen of a floating habitat, suspended in the upper cloud layers. Here the atmosphere is a cocktail of hydrogen and helium. Jupiter is the most massive planet, with gravity that would make you feel incredibly heavy. But the physics of its air is surprisingly light-hearted. Because hydrogen and helium are the lightest elements in the universe, Sound travels through them at nearly 1,000 meters per second, 3 times faster than on Earth. This creates the helium balloon effect on a planetary scale. Even if you were a massive, muscular Jovian human, when you opened your mouth to speak, you would let out a comically high-pitched, squeaky trill. Your voice would be loud, and it would travel for vast distances, but you would sound like a frantic chipmunk. However, you would constantly be in a shouting match with the planet itself. Jupiter is a violent world of constant thunderstorms and winds that create a permanent, low-frequency roar. Your squeaky voice would be a tiny, frantic melody, played against the backdrop of the solar system's loudest percussion section. You would have to yell with all your might just to be heard over the crackle of Jovian lightning, which is hundreds of times more powerful than anything seen on Earth. Imagine a world where every storm sounds like a continuous explosion, and the only way to talk to your neighbor is to chirp like a bird at the top of your lungs. It is a place of grand scale and ridiculous sounds, a cosmic irony where the largest planet makes you sound the smallest. The radiation on Jupiter is also intense, meaning your skin would need to be dark and thick, and your eyes would likely be small and recessed to protect against the glare of the megabolts. You would be a powerful, armored being with the voice of a cartoon character, living in a world of golden clouds and terrifying roars. Further out, Saturn offers a similar experience, but with a more turbulent, wind-swept twist. Like Jupiter, its hydrogen-helium mix would turn your voice into a high-pitched soprano. But Saturn is the wind king of the gas giants. At the equator, jet streams move at 1,800 kilometers per hour. This means the very air you are speaking into is moving faster than a speeding bullet. If you spoke into the wind, your voice would be whipped away and shredded before it could even reach your own ears. Communication would be nearly impossible without specialized equipment. You might hear your own words echoing through the methane-rich clouds, distorted by the sheer velocity of the atmosphere. Saturn is a world where sound is a fleeting, fragile thing, instantly captured by the planet's rotation and carried away into the vast, golden storms that circle its rings. To speak on Saturn is to realize how small a human voice is compared to the momentum of a giant. The temperature here is also a factor. At minus 178 degrees Celsius, the air is incredibly brittle. Sound waves would encounter different layers of gas density as they traveled, potentially causing your voice to skip or refract, appearing to come from a different direction than where you were standing. It would be a hall of mirrors, but for your ears. You would need to evolve specialized lungs capable of extracting oxygen from water vapor or synthesizing it from the ammonia ice found in the clouds. And your ears would likely develop large, forward-facing pinnae to catch the fleeting echoes of your fellow Saturnians. Finally, we reach the edge of the system, the ice giants, Uranus and Neptune. These worlds are staggeringly cold, and that cold changes the texture of sound. On Uranus, the air is thick with methane and hydrogen sulfide. If you could survive the smell of rotten eggs long enough to speak, your voice would be high-pitched like it was on Jupiter, but it would feel thicker and more sluggish due to the extreme temperature of minus 214 degrees Celsius. It's a lonely, frozen soprano sound, echoing through a world that is largely featureless and bland. Then there is Neptune, the final outpost. Neptune's atmosphere is a constant, deafening howl. The winds here are the fastest in the solar system, moving at 2,400 kilometers per hour. This creates a background noise so loud that it would drown out almost any human sound. Even with your high-pitched, fast-traveling voice, you would be a silent ghost in a world that never stops screaming. Neptune is the final reminder that our voices are a fragile gift, perfectly tuned to the specific pressure and warmth of Earth. On any other world, we become unrecognizable. We become giants on Venus, whispers on Mars, and cartoons on Jupiter. It makes you realize that the simple act of having a conversation is a luxury provided by the thin blue line of our atmosphere. So the next time you speak, remember that your voice is a piece of Earth itself. You aren't just making noise. You are participating in a biological and physical miracle that only works because of the ground beneath your feet and the air in your lungs. In this cosmic journey, we have seen that sound is more than just communication. It is our connection to the reality we inhabit. On Earth, we are poets and singers, but on the other planets, we are merely survivors, trying to make ourselves heard. Whether it is the bone-shaking rumble of Venus or the frantic squeaks of Saturn, every world has a song to sing, but only Earth allows us to sing it clearly. If you were born in space, you wouldn't just look different. You would think, hear, and speak in ways that a human on Earth could never truly understand. We are children of our atmosphere, and our voices are the most profound evidence of the home we have built in the stars.